Okay, last chapter we learned how to multiply exponents so we would be able to complete the problems found in this section. Before we begin, let's review multiplying exponents by simplifying the following problems. If you remember, when we were multiplying powers, we kept the base. So on number 1, we are going to keep the base of x, and then we added the exponents. So 3 plus 5. So final answer on this is x to the 8th power. When we started dealing with constants, we would go ahead and multiply those constants, and then we would apply the product of powers to our exponents. So we had 2 times 7, and then we had x to the power of 8 plus 4. So actually multiplying constants together, adding the exponents, we end up with x to the 12th. Okay. Same thing looking at this one, again focusing on constants. Then go ahead and look at those exponents. Negative 3 times 7 is a negative 21. We have x to the first. We are adding that to x to the 4th. So we have x to the power of 5. So keeping in mind again, we multiply the constants and then we add the exponents of powers. Last one here. I have just a 3. I have a 1 out there, so 3 times 1 is 3. I have x squared and x to the 4th, so that is x to the 6th power. And then I have just a y squared. Okay, went through that kind of quickly, but I'm hoping that we all remember that, and that was a nice review for what we are going to do on this next one. So again, let's take this concept of multiplying powers and combine it with the concept of the distributive property. So what we are doing is we are basically making a 2-for-1 problem where we are going to have to distribute that 2x to the x to the 3rd as well as to the 7. We're going to have a 2x and we are multiplying it by 7. I'm going to write that the other way. That way I can see a negative 7 and I'm multiplying it by a 2x. So I'm distributing to each of those pieces. Then I'm going to apply those concepts we just talked about. I have a 2 times a 1. I have an x to the 1st times an x to the 3rd. So I have an x to the 4th. I have a negative 7 times a 2, which is a negative 14. And I have an x. So again, we're distributing that term through, which means that we're probably going to be doing some multiplying of powers. Okay, so again, let's look at what we're doing. To start with, I would highly recommend writing each of the pieces out. That I'm taking 4 times 8, I am taking x squared, and I'm multiplying that by x to the 3rd. And then I'm adding that, I'm running out of room, to 4 times 5 and x squared times x squared. So here's my two terms. I have 4 times 8 is 32. I have x to the power of 5. I'm adding that to 20 times x to the power of 4. Okay, so again, 2 problems in one. Understanding that we have to focus on distributing that negative 2x to each power. So again, negative 2x times 5x squared minus 3 times negative 2x. So what do I get? I get a negative 10. This is an x to the 1st times x squared, which is an x to the 3rd. Negative 3 times negative 2, positive 6x. Again, one of those that does take a lot of concentration. Don't rush through it. We have to make sure that we get every piece. This x to the 4th. So on this one, I have 5xy times an x to the 4th plus a 6x to the 4th times an x to the 4th. So my 5 stays the coefficient. I have x to the 1st times x to the 4th, x to the 5th times a y. plus x to the fourth times x to the fourth is an x to the eighth. So this is what's called multiplying a polynomial, because here we have many nomials, many terms, by a monomial, by one term. So we are taking that one term and we are distributing it through. And that's what we're going to learn in this section. So go ahead and get out the notes and vocab for this section. Okay, objective of this section is to multiply polynomials. Remember that we are multiplying a polynomial with many terms by a monomial with one term. There is a lot of just drill and practice type of problems in here, but again, don't get frustrated with that because this concept is very important for many of the chapters later on. Again, when we multiply this, we just learned that we are using that distributive property for each one of those. So I'm going to write out each one. I have 7x squared that I'm multiplying by negative 3x squared. I have negative x that I'm multiplying by negative 3x squared. I have a positive 4. Again, to start with, this is a nice step to do just to keep ourselves focused that we understand what we're looking at. We have a negative 21 x to the fourth because I am adding those exponents. This is technically a negative 1 right here. So I have a negative 1 times a negative 3, positive 3. This is the power of 1. So that is an x to the third. 4 times a negative 3, negative 12, x to the power of 2. So a lot of distributing and then understanding all of the rules on how I multiply either constants or exponents. Okay, stay focused and give it a shot for guided practice 1. Okay, these problems are pretty straightforward. The only frustration is making sure we understand to go back and forth from multiplying our constants to adding exponents, multiplying constants, adding exponents, and so on. Example 2 is the same concept, except we are actually substituting in two different terms. So here we are distributing in, distributing in 2p, and here we are distributing a negative 5. Okay, 2 times a negative 4, negative 8. P to the first times p squared is p to the third. Okay, I'm not going to do this step up here because hopefully we're starting to get into the role of understanding how to do that, into that groove. 2 times positive 5, positive 10. P to the first times p to the first is p squared. Then I'm going to distribute the negative 5 times the 2 is negative 10. P squared comes along for the ride. Negative 5 times the positive 20 is a negative 100. Okay, same concept, it's just here we're distributing two different pieces. So, simplified? Nope, it actually isn't, because look at this. We do have like terms. So now we're going to have to combine our like terms. Notice what happens to them. They actually cancel out. So, final answer is negative 8p to the third minus 100. Okay, something that we didn't look at up here because we were just distributing through, so they were nice enough to put it in standard form. Remember that? Highest degree to lowest degree. That leading coefficient is negative 18. Here they were both in standard form, but once we distributed through, we actually received two like terms. So do make sure to double check that before you're done. Okay, moving on to guided practice 2. Okay, when we do these type of problems, one thing I want to bring up is that we have so many different things going on. We are multiplying the constants. We are adding the exponents. Once we get down here, combining like terms, we're adding the constants. We're keeping the bases the same. So keep that in mind. That again, try to say this in your mind, understanding what operations you are doing for each one of these different steps. Okay, 2b is kind of an interesting one because when we do distribute all of this through, we have some pretty crazy looking terms. So when we're combining like terms, we have to be super picky. We have to make sure when we have multi-variables going on that they're exactly the same in order to combine them. We have the same variable, same power, same variable, same exponent. So we could combine our 75y squared t squared with our negative 2y squared t squared in order to actually get 70 3 y squared t squared. Okay, now let's move on to a geometry type of problem. It says the theme for a school dance is called solid gold. For one decoration, Kana is covering a trapezoid-shaped piece of poster board with metallic gold paper to look like a bar of gold. If the height of the poster board is 18 inches, how much metallic paper will Kana need in square inches? Okay, well, let's look at this. She says that the height right here equals 18 inches. So first off, we have to figure out what the area is for a trapezoid. So going back to our geometry years, we know the area is 1/2 height times base 1 plus base 2. Okay, well, without knowing that height just yet, this is what we have. So we have area equals 1/2 height. This is going to be our base 1. This is going to be our base 2. So base 1 is h plus 1. And then we are adding that to base 2, which is 2h plus 4. So first thing it looks like we have to do, I'm going to keep that 1/2 height to start with, and then I'm going to go ahead and combine like terms here. It looks like I have 3h plus 5. Okay, then I'm going to keep going with that, and it looks like I have to distribute this 1/2 h through. So what is 1/2 times 3? 3 over 2, and then I have h squared plus, what's 5 times 1/2? 5 over 2 h. Okay, with that in mind, now I can go ahead and plug in that 18 because I only have a couple of those variables that I have to deal with. So area equals 3 over 2. They tell me that my height is 18. 5 over 2, and then I plug in that 18. Again, let me get out the calculator to show you how to effectively put this into your calculator. Okay, remember dealing with fractions, we do have to put that parentheses around it, so 3/2, and then we are going, we have to put a parenthesis around our 18 because we are squaring that 18. Remember, we do have a fancy squared button there, plus 5/2, and we are multiplying that by 18. So only having to put this into the calculator one time, and we end up with 531. Okay, so we know that the area of this is 531. Let me go back to what we're talking about, inches squared. Okay, so how geometry comes into play with situations like this. All right, go ahead and try guided practice 3. Okay, this is a good problem because these are the type of problems we're going to see later, where we have a base of the bandana of the collar, but we want to add on 4 inches to each side in order to have enough room to tie it on. They say that the height is 1/2 of the collar length. So when we start looking at how to design things later in life, these are the type of problems that we're going to look at. So we know that the area of a triangle is 1/2 base times height. Our base is the collar plus 4 on each side. So I said that our base is c plus 8. Maybe I should put that up here so we understand that. Our base is the collar plus 8 inches on each side. Our height, they said, was 1/2 of the collar. So that's why I plugged in that 1/2. I went ahead and combined the 1/2 c times the 1/2. So I got 1/4 c times the c plus 8. And then I distributed that through. And then I plugged in the 12 because they said if her dogs have a collar length of 12 inches, how much fabric do I need? 60 inches squared. With that same formula, I went ahead and plugged in 6 inches for the bottom one. So again, we're going to see a lot of geometry type of problems later where maybe we want to extend something or maybe we want to shorten something, and we want to see what that does with our outcome and how many square inches of something we need. Okay, last thing we're going to look at is how to solve equations. It's been a while since we've solved equations, so let's go ahead and see if we can remember what to do. This is a huge, long problem, but looks like Step one, anytime that we solved problems, we had to distribute. So that's what I'm going to do with each one of these. Notice there's an equal sign right there, so we have to keep that in mind once we start dealing with that. Okay, here we go. I have 10. I have a squared. I have negative 4a. Then I have a positive 6a squared. I have a positive 18a. I'm adding an 8 to that. I know that that is supposed to equal a 4a squared plus an a, because a times 1 is just an a, plus a 12a squared minus an 8a. Then I have to add 50 to that. A lot of stuff going on, but let's go ahead. There's my equal sign, so I'm going to focus on everything on this side and combine like terms. So it looks like I have 16a squared. I have a positive 14a, and I'm adding an 8 to that. There's my equal sign. Now I'm going to go ahead and combine like terms on this side. Looks like I have 16a squared. I have negative 7a, and I have a positive 50. Okay, so I distributed. Now it looks like I'm supposed to combine like terms. So I have to get rid of this 16a squared. I'm going to go ahead and subtract that from each side. So I didn't really go over the fact that we haven't ever solved an equation with a square in it before. We've always dealt with linear. Well, we're not quite there yet. We will, actually. Next chapter, we will start solving equations like this. But right now, we just got rid of it, which was really nice. So we're down to 14a plus 8 equals negative 7a plus 50. So that was a relief because we now know what to do with this. We are just down to one term that has an exponent of 1. Since he's negative, I'm going to add him over here. 21a plus 8 equals 50. Now it's just down to add or subtract. I get 21a equals 42. Then I multiply or divide, and I see that a in that whole ugly mess, if I plugged a 2 in there, everything would be balanced. Okay, so again, a lot of drill and practice on that. That's just showing us step by step by step. We will see some squares in there, but they will disappear. This is just getting us back into that solving equation thing. What can I plug into this equation to balance out each side? Okay, last guided practice, go ahead and give it a shot. Man, that first problem had a lot of steps, but again, understanding distributive, this was kind of tricky. They had parentheses around there. Really what that just meant was we were multiplying a 1 through there, so I just dropped the parentheses, knowing that I'm focusing on distributing this 2x through. Combining like terms got rid of that square, so then I was just down to what we have learned in the past. We should have ended up with 13 over 5. Over here it was nice because the squares were on the same side and they canceled out right away. I did go against my usual rules and I subtracted the 90 over here just because that way I eliminated a step, because if I would have subtracted the 7 over, I would have had to add a 16 and then divide by 2. So I did deal with the negative for just one step and got down to d equals 8. Okay, biggest thing here is, yes, you are going to be dealing with a lot of different concepts. So make sure, again, we understand when we are multiplying constants, when we are adding exponents, when we are combining like terms. So go ahead and remember all of those different concepts for the assignments for this section.